let's do this. See this diagram. Chords A and B, AB and DL intersect at point M. FC is tangent to the circle. D lies on CL. If DM and ML are solutions to the equation x squared minus 40x plus 51 is equal to 0, AM and MD are integers greater than 1 and CF is equal to 15. Find the value of AB plus CD. Okay, let's move this diagram and enlarge it. This is better. We know that CF is equal to 15. AB and DL intersect at point F. Okay. FC is tangent to the circle. Cool. And D lies on CL. Okay. If DM and ML are solutions to this equation. Okay, let's solve this. X squared minus 40x plus 51 is equal to 0. So we have x minus 51 is prime, I think. No, it isn't. It's 3 times 17, maybe? It's 3 times 20 minus 9. No. Oh my god, I can't even think. Minus 3. Yeah, it's 3 times 17, right? Yeah. 3 times 17. But 3 and 17 don't add to this, so I don't think it's going to be integer solutions. Shoot. X is equal to 40 plus or minus the square root of 40 squared minus 4 times A times 50. What? Oh, yes, all over 2. Okay, I see. So, take out, we have 20, plus or minus, we take out 4, so it's going to be 400, 10 times 40 minus 51. So 400 minus 51 is 349. 349, which is it's not a factor, it's not a multiple of 9. 9, 16, no. 25, no. 4, no. 36 is 9, no. 39 factored is going to be not 3 times anything, not 5, not 7, no. It's not 7, not 9, not, well, okay, so if we have 20 times 20, 17 times 17 is going to be 49, 140, and 100. It's going to be 9, 200, isn't 20 squared 400? What the heck? What the heck? Oh, it's 18 squared. 64, 120, or 160, 100. It's going to be 324. Wow, okay, so 324, so it's going to be slightly above 18 squared. So only we need to check below 18. So it's not a multiple of 9, it's not a multiple of, is it a multiple of 11? We have 330 plus 16, no. It could be a multiple of 13, 14, no. 15, no. 16, no. 17, maybe. 18, no. Okay, so let's check 13 and 17. 13, we do 260. 39 is 39. 299, 50, no, and then 17 is 340, and then 9. So this is a prime number. What? I have to be doing something wrong. Because there's absolutely no way. This is 40 times 40. I factor out 4 to cover the 2. What? How is this possibly correct? Okay, well, dm and ml are solutions to that, so... Well, at least... that's probably trying to tell us that the sum of them is, this entire thing is 40. Okay. A, B, and NB are solutions, are integers greater than 1. Then CF is equal to 15. CF is equal to 15. The value of AB plus CD. AB plus CD. Okay. Well, how can I possibly do this? We know that these two aren't equal because these aren't integers. But maybe this entire thing is equal? What would tell me that? Like, genuinely, how could I possibly know what this is? I don't even understand what is defining AB. I mean, the only constraint we have here is that it intersects with M, right? And we know this here and this here. But AB can still be anything. AB can be rotated. Although I guess that doesn't change their sum. I'm just trying to picture this. We have this. We have this. We have this. I bet there's some theorem that says that all chords through a point are of equal value. I bet. Because these look about equal. If you have, let's say we take the simplest case where we have a radius. This, they're all of equal value. There's diameters. Since we know the value of this, I mean, they look about equal. Can I test that? Like if I were to, can I do anything to test that, really? If I were to take my hand, this, this. I mean, this isn't a perfect circle anyways. I'm gonna guess that it's 40. This seems really easy for a, three-pointer. I have no other conception of how I could possibly do this. Let me check. Shoot, I just realized that, I only solved for AB. Now we need to solve for CD. CD is... Let's use some triangle stuff. Well, if I took a point that is... If I took the center of the circle, if I made this right here, this is a right angle. CD doesn't intersect with the center of the circle, so I don't know what I'm possibly doing. Maybe if I knew that M, the center, and F are all collinear, maybe that could help me, but I have no conception of what the radius of the circle could be. But I'd assume with a constant radius and a constant this length, given that we get a collinear point, I bet that or a tangent point, I bet that this is always the same length. This length is probably fixed given a certain diameter and a certain value of this. So if I could somehow find a formula for that, maybe let's redraw it like this. We're given a circle like this, and a line like this, and a certain radius r, then we have this here, which is also a radius. Whoa. So this is a radius, and then this is, we know this, we have this distance. So we could figure this out probably, because we know r squared plus d squared is equal to r plus question mark squared. So r squared plus d squared is equal to r squared plus 2 question mark r plus question mark squared. Cross these out, we have d squared is equal to question mark times r times question mark plus 2r. And then, given an r value and a question mark value, we can solve. Or given an r value and a d value, we can solve. So maybe let's just plug in our d value without knowing r. So, 15, so 225. 225 is equal to r. I'm just going to write 2r question mark plus question mark squared. Maybe if we find r now, we can figure this out. We have no easy r value. That's an issue. Which is an issue. We don't have any radiuses here. None of these are radiuses. If I could somehow prove that these are collinear, could I say, hey, this distance is the same as this distance? Which means, no, I couldn't even say that those are the same distances. Maybe I could do it with this here. But I don't know that either of these are collinear with the center, actually. Realistically, I don't know that any of these are collinear to the center. And given... Well, I mean, 2 points are always collinear, but I meant collinear with F in the center. So, what is the way that I can figure this out? I can use this tangent C here, I can build a right triangle with the stuff I need, and then I can figure it out. But I cannot build a right triangle with the stuff I need, because the stuff I need does not intersect in the correct apparatus that I need to intersect in. Well, given that I got an integer here, this must also be an integer. So maybe if I could eliminate values of these that cannot be integers, then I can get a correct answer. Maybe, I don't know. No, 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 no. No, 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 no. Oh no, it doesn't even matter because 225 is equal to question mark plus 2r. Then I can make r anything I want, and then I can change question mark to be anything, this value to be anything I want. So even if I got an integer factor here, this does not necessarily, this can be any integer I want it to be, so it doesn't even matter. It doesn't even have to be an integer in the first place, because r can change variably to whatever I want it to be. So, I'm stuck. I'm no quick answer. I have absolutely no idea how to get this. But I am keeping my guess that the AB is equal to 40. Let me check. Guys, they just pulled equations out of nowhere. They just pulled equations out of nowhere. They said, well, I could have figured this out if I wanted to. I could have figured this initial first step out. dm and ml are solutions to this equation. So I said that dm times ml is equal to 51. Which I could have gotten. But for some reason, they also said that AM times MB is also equal to 51. Which is like, why is the equivalency a multiplication, not a addition? I don't know how, whoever derived this, but whoever derived this, God bless you, because I would have never figured this out. I mean, no, they don't even explain how to get the answers, bro. But then they figured this out because they said, oh, these have to be integers. What are the two integer factors of this? 3 and 17, since it can't be 1 and 51 because they're integers greater than 1, so it can't be this, so it has to be this. So we'd say, oh, this is 3, this is 17, so then the sum is equal to 20. And they also got this weird equation somehow, I don't even know how they got it, where it's FC squared is equal to CD times CD plus DL, which is kind of even similar. I don't even know how they got it. It's similar to the equation that I got here, with a variable times a variable plus another variable. So it is similar, but it is, I don't even know how they even derived this. I don't even know how they freaking got this. They don't explain it at all, but at least they showed me that it's this for some reason. If somebody could please explain it, that would be very helpful, but yes, I don't know what I'm going to do, because I failed. But hopefully the next problem will be easy, so cool. Thank you guys for watching. I'll see you guys tomorrow. Goodbye.